Application of building envelope systems relative to fundamental performance. Note, the application of the building envelope system is not only limited to its fundamental performance, but rather it can be also relative to aesthetics, moisture transfer, durability, and energy and the material resources. Later on, my remaining groupmates will discuss this one by one. Meanwhile, my report is solely focused and entirely anchored to that fundamental performance. Now, when we talk about the performance of the building envelope, we firstly need to know the definition of the performance. So what is performance? Performance refers to the desired level or standard to which the system must be designed for a given requirement. This means that the envelope has to respond to both natural forces and human values. The natural forces include the rain, snow, wind, and sun. Human concerns include safety, security, and data success. The envelope provides protection by enclosure and balancing internal and external forces. Earlier, I mentioned that the system must be designed for a given requirements. What are these requirements? The fundamental requirements. First on the list is the structural. If the wall is not part of the main building structure, the building envelope must support its own weight and transfer lateral loads to building frame. Second, the water. The envelopes resist water penetration. Third is the air. The envelope resists excessive air infiltration. Fourth is the condensation. They resist condensation on interior surfaces under service conditions. Fifth is the movement. They accommodate differential movement caused by a moisture, seasonal or diurnal temperature variations, and structural movement. Six is the energy conservation. They resist thermal transfer through radiation, convection, and conduction. Seventh, the sound. They attenuate sound transmissions. Eighth is the fire safety. They provide rated resistance to heat and smoke. Number 9 is the security. They protect occupants from outside threats. Number 10 is the maintainability. It allows access to components for maintenance, restoration, and replacement. 11th is the constructability. It provides adequate clearances, alignment, and sequencing to allow integration of many components during construction using available components and attainable workmanship. Number 12 is the durability. It provides functional and aesthetic characteristics for a long time. Number 13 is the aesthetics. They do all of the above and look attractive. And last but not the least is the economy. They do all of the above inexpensively. Now that we already know the fundamental requirements, how can we assure that the building envelope will function accordingly? To have a properly functioning building envelope, the system needs to have these 4 key elements: support function, control function, finish function, and the distribution function. Support function. Enclosures must be capable of withstanding all the internal and external forces applied to them. The majority of these forces are structural loading. These loads include both static and dynamic loading, including but not limited to live loads, dead loads, wind loads, earthquake loads, and possible blast loads. These loads have to be properly supported, resisted, and transferred. It is to ensure strength and rigidity, providing structural support against external and internal forces and loads. Imposed load, or most commonly known as live loads, are temporary or a moving load. These dynamic loads may involve consideration such as impact, momentum, vibration, dynamic of winds, and material fatigue. Dead loads. Dead loads are relatively constant over time, including the weight of the structure itself in immovable fixtures such as walls, roof, plasterboard, or carpet. Dead loads are also known as permanent or static loads. Building materials are not dead loads until constructed in permanent position. Wind load. Wind load is used to refer to any pressures or forces that the wind exerts on a building or structure. There are three types of wind load. The uplift load. This can be the wind flow pressure that create a strong lifting effect. Wind flow under a roof pushes upward, or the wind flow over a roof pulls upward. The second is the lateral load. It is the horizontal pushing and pulling pressure in walls that could make a house slide off the foundation or overturned. The third one is the shear load. It is the horizontal wind pressure that could cause rocking of walls, making a house tilt. The second function is the control function. The control function refers to the ability of building envelope to control and moderate the exchange of mass, or this could be an air or moisture, and energy or heat, sound, fire, light, etc. due to the separation of interior and exterior environment. These exchanges between the external and internal environment include heat, or the controlling thermal exchange between the inside and outside environment, the wind, the controlling airflow due to leakage, wind pressure, or internal partitioning, the moisture, controlling moisture transfer due to rain, vapor, diffusion, or condensation, the sun, controlling solar transfer from penetration or dealing with the insufficient natural lighting, sound, or controlling ambient sound, excessive sound, or sound due to vibration. Fire, control the spread of fire within a house from the inside or outside through the use of fire doors or windows. The third function is the finish function. The finish function at both the exterior and the interior is the aesthetics of the finished surface, the visual, textural, and other aspects that the designer wishes to convey with the visible elements of the system. Of all the elements of an enclosure, wall systems typically have the largest consideration for finish. The last function is the distribution function. This function relates to the distribution of services through a building. This includes the distribution of power, communication, water, and its various forms, gas, and the conditioned air, to, from, and within the enclosure itself. Examples include HVAC, water heating, lighting, thermal envelope, and the miscellaneous electrical load system. Now, as we nearly come to an end, it is awesome to remind everyone that the building envelope is the part of a structure. That means that it can be regulated in terms of its design and forms by the following codes. The National Building Code of the Philippines, concerned with the acceptable standards designs for building envelope. Philippine Green Building Code, a referral code to the NBC that seeks to improve the efficiency of building performance through a framework of acceptable set of standards. The National Structural Code of the Philippines, also a referral code to the NBC. And last is the Fire Code of the Philippines, which is for the installation of fire-resistive walls.